everybody, welcome to this webinar for Advanced Steel, The Secrets of Stairs. My name is Alec Giles and I work for Graitec UK. So a few words about me first. As I say, I'm a structures consultant at Graitec UK. I originally trained as a mechanical design engineer around 30 years ago. I spent about 10 years designing machinery for the steel and aluminium industries. But then I moved sideways to become the CAD manager at the company I was in, where I started supporting and training all the CAD users using AutoCAD Mechanical, Inventor and Solid Edge within that company. Then I moved to Graitec 10 years ago, and since then I've been focused 100% purely on advanced steel, training and implementing that. So that's me. Why should you choose Graitec as your partner for the software? Well, Graitec are unique. We can offer you services across the entire life cycle of your product, and we like to split that into 4 areas. First of all, we have Graitec Create, where you're using Autodesk market-leading software products to design your product, but those are enhanced further using Graitec Power Packs. And we have Power Packs available for Advanced Steel, for Inventor, for Revit, and for Volt. Once you've got your basic design, you need to test and simulate that design to make sure it's going to really work, so you can use the market-leading Graitec software to do all the FEM analysis on your products to make sure it's going to really work in the real world. It's got market-leading technology, advanced features, but still very easy to use. Once you're happy with your final design, you need to actually manufacture it. So then we move into Graitec Fabricate, and we have tools available there which can control and manage your entire workshop. That includes everything from stock control, running your NC machines, feeding the right NC file to the right machine, and also managing your human resources so you can tell which man to pick up which parts and weld which things together, and scheduling and programming all of that into the efficient use of your workshop. Obviously, all of that is going to create a lot of data flying around your company, so to help you with that, we have Graitec Manage, where we have tools available there to manage all of your work in progress data as it moves around your company, protecting your IP, making sure everybody's using the right version of the right data at the right time, everything up to the point where you can pass it to a third party outside your company or into an external common data environment. And Graitec are unique in being able to help you throughout all that life cycle of your product within your company. We talk to us and we can help you. This particular webinar is one of a series of webinars. We run different series of webinars every few months, and you can see there a list of the current series. We're in the middle of that. If you'd like to register for any of those, you can follow the link at the top right. This presentation is available as a handout if you go to the handouts panel of the GoToWebinar interface, and if you download that PDF, all these links will be live for you to click on so you can jump straight to the right places. If you also want to keep up to date with all the announcements of any future webinars, go to that events page and register there, and you'll get emails telling you about all future webinars so you never miss ones that are coming up. Graitec offer a massive amount of content online. First of all our previous webinars. If you do miss this one, or obviously you're here now, but if you miss any other webinars, then you can go to the Advanced Steel Content Portal, and all of our previous webinars are recorded and listed there. There are over 50 there at the moment. That's over 40 hours of content for you to watch on demand. This particular webinar will be recorded and added to that content portal within the next few days. Do you get our Advanced Steel blogs? We like to publish blogs regularly, little short bite-sized chunks with tips and tricks for Advanced Steel, how to get more out of it, how to make things more efficient. There's over 100 available already, and there's a little envelope icon on that web page where you can click on that to subscribe and be informed about all the new ones we post. We recently enjoyed an online Advanced Steel User Day with our UK customers, and we've also got many Advanced Steel presentations in the BIM Up conference from Graitec in 2019 and 2020. All of those are all recorded as well, and they're all available on the Graitec Advantage website, which is an exclusive website for customers only. If you are a customer, you should have a login. So log into the Graitec Advantage, go to videos, and you can watch over 20 hours of content for Advanced Steel, among all the many other 120, 150 classes for other products as well. And finally, if you're a Graitec UK customer with support for Advanced Steel, you're definitely entitled to have the Advanced Steel Power Pack. If you're not a UK customer, then please consult your local Graitec office for information about that. But the Graitec Advanced Steel Power Pack is extra tools, extra bells and whistles on top of the standard Advanced Steel to make your life more efficient and easier. If you don't have it or you don't have it installed, contact your nearest Graitec office and we'll help you sort that out. So this particular webinar then, well, it's all about stairs. And we're going to start off using the standard staircase macro within Advanced Steel. And we're going to review how to get the best out of that. So first of all, you need to know the right set out points to use. We'll discuss those so you can make sure you're using those correct points. If you start with the wrong points, everything else will fall apart and go wrong as well. Once you've got the set out correct, we'll look at the basic options and values within the data, within the macro. So make sure you get the right settings. And we'll also discuss how to use the library entries for maximum advantage as well. Once we have your basic flight of stairs in there, we'll look at populating that around the rest of the model to make full staircases. We'll manipulate the top and bottom treads, they can be different. And we'll also put in some landings. So we'll have a half turn landing and we'll have an intermediate straight landing, 2 types of landing. So we'll make 2 different staircases, give you a good range of functionality shown there. And if where the macro can't do everything perfectly for us, it'll show you how to manually add what you need without breaking the macros. So the standard stair macro then. First thing to always remember with any macro, no matter how powerful it is, all macros are going to be limited somehow. They're never going to be able to do everything conceivable within just one click. So what you need to do is remember that the macro can probably do 85, 90% of the work for you, maybe more, maybe slightly less, depending on how advanced and how unusual your stair is. Standard stairs, it will do everything. Other stairs, it might only do 85, 90% for you. And then you can adjust and manipulate manually after that. But it doesn't mean you shouldn't use it. It's still worth using it to get that head start. The very first thing you need to do is to put in your set out points correctly. So we strongly recommend, although with 3D modeling in Advanced Steel, you basically just use some simple 2D AutoCAD lines to draw in some construction lines and some construction points. And if you get these right, everything else drops into place. If you get these wrong, you'll never get anything else right. So the 2 or 3 minutes spent doing this is well worth investing. And in the case of the standard stair macro in Advanced Steel, what it uses as its reference is the nosing line from finished floor level to finished floor level, top and bottom. So the nosing line is the imaginary line connecting the front corner of each tread on your stair. We always know the total rise we require for a given stair. Obviously, we know where the finished floor level is, so we can calculate that total rise. Always working from finished floor level. If you're going just to steel beams and you're going to have a grating on top, remember to allow for the thickness of these gratings and so on when you're working out these points. Typically, though, the architect might give you the length of the stair to the front of the first tread. That's no use to us. Remember, we need where the nosing line is hitting the floor. So that's going to be an extra going on top of whatever the architect gives you to that first tread. It has to be where it hits the finished floor level, top and bottom, where I've put the stars. Calculate where those 2 points are. Sketch out in your model using construction lines where those 2 points are. Doing that, everything else will drop into place. One final comment here is about the rise and the going. There's a lot more to a stair than just the angle. You could have this stair at this angle, but if you only had 3 huge steps, it'd be really difficult to climb the stair, really uncomfortable. Or if you had the same angle, but with 100 little tiny steps, then again, you'd be on tiptoe trying to go up these hundreds of little steps, and it'd be really difficult to climb, really uncomfortable, not nice. So instead of using just the angle for a stair, most building regulations use a formula based on the rise and the going, and that's twice the rise plus the going, or 2R plus G, and the total has to be a certain number within a certain range, depending on what type of stair it is, what type of building it is, how often it's going to be used, and so on. So the macro in Advanced Steel is built around this 2R plus G formula as well. So again, get the nosing points and the construction points correct, the rest will drop into place easily. But if you don't get these construction points right, you'll never get the right rise and going. And basically, easily putting in the angle is of little use. Okay, so let's have a look at that in action then. So here we go into the model then. Let's have a look at what's going to happen. So we have our model here, we've got the platform in the middle, but we're going to do two staircases around it. You can see we've already got our construction lines. Drawn in. You need to know where the top and bottom of the nosing line is for each flight and where the landings are going to go. You don't necessarily have to draw in each step as you go. So we're going to start with the straight stair macro. And first of all, it's going to be using the start and end point, so 0 there, the default. And you have to pick the bottom point first. So I'll use an end point on the bottom of this line for the first point, and an end point at the top of the diagonal line for the top point. And we want that stair in the middle, so that's the one. So now we have a stair. And looking at that stair, the first thing to notice about it, if you go under distances and stringer, is that the width is currently locked. The reason it's locked is because the steps that we have are set to be a grating, and it is a standard grating of fixed width. So if you change that to variable grating or a different tread type, you can now go back to the distances and stringer and change the width to whatever you wish. If you go under steps general, we can see it's calculated the rise and the going for us, but they haven't calculated the ones we particularly want. So we can take the tick out of this box and simply set the rise or the going we want. So set the going here to 230, and that recalculates the other two values for us, and now it matches our construction lines. For the stringers, let's make sure we've got the right offset and position for the stringer. We've got the right section there, channel, that's good. I'm going to set it so it's in front of the nosing line here with a 10mm offset. There you go. The nosing line does not move, it's the stringer that moves. We don't actually want gratings for our treads here though, so we're going to go to tread type. We're going to change to type 7, which is a folded plate tread. And we're going to have a look at the options here. It's really important to get this connection between the bracket and the tread, bracket and stringer correctly. We want the bracket welded to the stringer, so that should say bolted welded. The screws are too chunky, so I'm going to change the screws now as well. I'm going to choose an M12 countersunk screw. And the next option is one that's easy to forget. At the bottom here, we have bolt and weld location. You need to decide whether it's all one large piece or split up where the bolts are. So the bolt should be done on one site, so that should change to site shop. Now we look at the tread dimensions, and we need to adjust a few of these. First of all, we want the thickness of the plate to be 6mm. We need to make this tread a bit deeper, so it overlaps, so that's going to be 245. The front again will not move as the back goes backwards. To make it overlap, we want the lip to be 140 on the back. And of course it won't work unless the angles are 90 degrees, so we set these two angles to 90 degrees. You can see the stair updating as we go. So now we have the treads overlapping each other. So tread dimensions 2 is all about the angle bracket underneath. First of all, we'll make sure we choose the correct bracket. So I'm going to change that to an unequal angle, 100 by 50. And we can adjust the other parameters to go with that. So let's move the bolts to the middle of the leg. Probably change the length as well. To get the centers right. That looks a bit better. Now, we could change the steps, but we're not going to change the top and bottom steps. We're going to go to the landings now. We don't actually want a landing at the top yet, so we're going to turn that off. So that now gives us our basic stair structure. We can use that structure and go to the library, most of the time you're probably going to want a similar stair, or if you do want the same stair repeatedly, you store the values in the library. So import values, and that gets all the basic parameters stored for us rather than set all those values over and over again. Now we edit and we give that a decent name so that we can recognize different configurations later on. Just putting a decent name here describing the stair. That's the springer. Let's go out. So treads. Okay. So we've created our first basic flight of stair. Okay, so having done the first flight of stair, a few points to remember about that. First of all, the width of the stair is originally locked or fixed. You can't change it. That's because when you first place the stair, it creates it with a stair tread type 1, which is a fixed grating. So you can either change that to a variable grating or to a different type of tread altogether, and then the width will become unlocked. So you can change it to anything you like. Don't forget to set the bolt and weld location on the tread type page. There's no visual clue as to how that is set, but of course it can make a big difference whether you can have 2 stringers and a pile of treads delivered to site, or whether you're going to have the whole stair as one single unit delivered to site. It will soon become apparent when you do your drawings, but you really want to remember to set that at the time of creating the stair. And it's well worth saving your common configurations of stairs to the library. Even though every stair might be a different angle, if you save the basic configuration to the library and call that up again in future, probably only the rise and going is going to be subtly different. So it's going to be 1 or 2 variables on the tread dimensions page or on the distances and stringer pages, just to get that fine-tuned. But you're not going to have to remember 30 or 40 different options about all the bolt types and everything else to get everything else set just how you want it. There's only going to be a couple of options to change, so that's well worth doing. So we've got our first flight. We need to populate this around the rest of the model now. So we're going to look at copying this staircase around and finishing off the model. And while we do that, look out for the following points. You don't need to delete the joint box. You find some people are very keen on immediately deleting the joint box because they think they have to change one small thing. We do not delete any joint boxes at any point during this presentation. It's not usually necessary to delete the joint boxes. The top and bottom tread of each flight can be different to all the other treads. This enables you to create lots more options, lots more flexibility on how it connects with the landing or the finished floor at the top and bottom. The landing profiles themselves can be modelled, and you can put covers on top of them, or you can replace the cover with a top or bottom tread, which again, by adding the extra tread at the top or bottom, that can create a lot more options on how you mate up with the floors either side. And if the macro doesn't quite do 100% of what you want, you can still use the macro to do nearly all the work, and then without exploding the joint, you can fine-tune or manipulate what you've got to add extra features to complete the finished stair. And that includes you can copy elements from within the macro to other places to reuse them without having to model them all from scratch. So look out for those points as we now demonstrate the next portion for you. So let's have a look at that in action. Because the stair itself is basically a joint, we call it a macro, but it's just a big joint. We can copy that stair up. We've got the 4 flights we want there. We've only got the first one, so we're going to go to joint copy. Pick the joint. You can see it is a joint. And then we can just go along answering the same questions as usual. Turn on the endpoint snap to make it easier to pick the reference points. So I'm going to go from the bottom here to the top here. And this in the middle. Same for the next one. Bottom to top, in the middle, start and end, bottom, top, middle. So we've got our 4 basic stairs immediately, just like that. Now we can go around and adjust each flight as required. Turn off that endpoint snap again, we don't need that anymore. So going back to the first flight then, we need to set that to get that just how we want it on this particular position. So we can edit the joint properties. Let's have a look at this bottom tread. We've got a gap underneath that we don't want because you can trip up. So we can go to step bottom and notice it doesn't have to be the same. So we take the tick out of that, and now you can override the bottom tread to make it completely different if you want. We don't need it completely different, but we can make that front length 150. And you can see that the bottom tread now reaches the floor without affecting the other treads. Going up to the top, we want to start creating some of our landing here at the top. Now we want the beam on the right to be at the side of the landing and the beam on the left to be underneath the landing. So we can't do both at once with the macro. So we're just going to create what it calls the front, that's the right hand side. And we're going to have a look at what's going on. So we want to make that beam long enough to reach the back of the landing, 1230. And we're going to offset it 10 mil up. We're going to go to the cover. When you look at the cover, you could have different types. You can have a plate, you can have a grating, or whatever. And there are also options to say, instead of having the grating on top of the stringer, you can put the grating inside the stringer, mounted on angles. But we actually don't like that cover at all, so let's set that to none. And instead of using that, I'm going to go to the top landing page and tick Create Last Tread, which turns on an extra top tread. Like so. Now, because the top tread can be different to the others, I'm going to take that tick out here. And we can adjust the dimensions of this one now to make it as a substitute landing. So the depth, or the tread width, needs to be 1230. We don't want that back clip, so if I actually set the bending angle to 0, that removes the back clip for me. Now let's just have a look underneath. It's done the job, but those angles are at the very back there, so we want to adjust those angles. So tread dimensions 2. We can adjust the length of those to make them the full length. The only thing we have got to watch out for is that we're locked to only having 2 bolts. So I can put in the first 2 bolts, I'll have a 300 centres there, but I'll have to put in more manually later. So that's basically given us everything we can get from that first flight, and we're ready to move on to the second flight. So we'll go to the joint properties of that and have a look there. Again, we're going to go to the top landing and we're going to create both sides this time because it's a nice straight portion. We'll make them the right length. Turn off the cover and turn on the last tread. Once again, we can adjust that top tread to be different to the others. Oops, let's take the tick out. So, tread dimension 1, let's make it the right depth, 500, and remove that back clip again. And check out those brackets underneath. Adjust the dimensions of those. Like so. You can see the bolts moving. So that's the top. Now at the bottom, once again, we want one beam underneath and one beam up the side, so we're going to do one of the two. So we're going to do the right hand one. Get the right length. Don't want any cover. Unfortunately, on this occasion, we would like to try and use the bottom tread, but you can't turn off the front slip on the bottom tread, unfortunately. We've tried that. So instead of using a bottom tread, we'll actually manually create that. So now we need to draw in our various cross beams. So I'm going to go from the bottom of here with just a channel, bottom of that stringer, and I want to go forwards to line up with the end of the other stringer. So I can use the point filters, just I only want to go in the X direction, so I click on .x, and then I can snap to the end point, get 0 in the X and Y, snap to the end point of that beam, and it just goes the matching length. Do the same from these, so I want to track across from that one to get the end point of that, like so, and then draw it this way so I get the toes going the right way. Choose my section. Positioning. Don't forget to set the model bar. I'll draw a beam across the back as well, simply from corner to corner. A small one in here. And I'll move that small one forwards to support the other end of that platform. So that's what should do it. There you go. Now I can mitre up the different beams, and although some of them are part of the macro and some of them aren't, it still applies perfectly happily. I haven't had to damage the macro, I haven't had to delete the joint box, I can still apply the miters to these members with no problem whatsoever on both sides. I can weld these as well when I'm doing that, so I'll just double check and I'll copy that joint to the other side. Double check that the assemblies are correct, so I'm going to pick that stringer, yes, that's part of that stringer now, and the same on this side, yeah, that's part of the stringer now. So those landing beams are part of the stringers, and you've got the correct assembly structure there. So now I'm going to create some covers, and I'm going to put my UCS at the right position, so let's put it on the right height there. And I'm going to create a plate. I'll only use one reference point, so that's rectangular plate by centre on the end of that line, where the UCS is, and I'll adjust the dimensions accordingly. Set it to dirt bar plate, and get everything else set, the positioning and so on. There we go. So now that one's in the right place. And I'll repeat that for the middle plate as well. The corner of there to the corner there. And settle that correctly. So I've got my plates, but there's nothing holding them up there at the moment. I also need to do a lip to go underneath that bottom tread, so I can change my UCS. Don't forget to rotate it. Draw in one more plate. Choose the appropriate dimensions. Now I can create a folded plate between those two, and there you go, it's one piece. So just move my UCS to the middle of the bolts now, and I can touch up these bolts to support these plates. So I wanted more bolts on this one, so I can just add a single bolt between the angle and the plate. Put it in the position I want. Choose the right types. Okay. And I can copy that bolt as required. So that bolt goes forwards, and then I can copy both of these two bolts from this one as a reference to the one on the other side as a reference, and then put the bolts on the other side. So now I've got 4 bolts on each side of that landing plate. I now need to create brackets for the other landing plates. So I can do the transform elements, select the bits I want to copy. So if I try this beam, tell it to include additional connections, it's got the 5's found the bolts automatically. In fact, I don't know why I don't do both angles at once, so let's do both of them. There you go. And I need to tell it the distance to copy, so it's from the corner of that plate to the corner of this plate. I'm only going to check that. There you go. Let's copy those and add them all in. Now again, it should have copied all the rows and all the bolts. So it's just asking to select corresponding elements there. Now the thing is, you can't. There you go. You can see the angle is part of the assembly with the stringer now. We couldn't select the plate as a corresponding element, so we've got to choose the bolts separately now to add the plate in to those bolt joints, and there you go, they've adjusted accordingly. Because the folded plates are not the same as the beam that was used for the tread. I'm going to extend this angle backwards using the grip on the end. Same for this one. And we've got room for an extra bolt there, so let's just do a copy that bolt and that bolt along. There you go, so we've got enough bolts in that one now. Now the middle plate is sitting on top of the angles, so all we need to do is copy the bolts. Don't need to copy the angles. So I'm just going to copy that bolt, or those bolts from here. To the midpoint of that edge. And I only want to go in the Y direction, so I'll turn off X and Z, and it just does that direction for me. I can do that again. Select those three. And I'm going to go across the middle of that to the midpoint. The bracket there. And again, it's only going in the Y direction, so that copies those. Go back to realistic, and you can see we've now got all the bolts we need. So the landing was created with relative ease there, and the two staircase joint macros are still intact. As you can see, we've still got joint properties available. So we haven't had to break them in any way. We still could edit them if we needed to. Moving up, we're going to go up to the next flights now, where we've got the two flights in a straight configuration. I want to put an intermediate landing in, and I want that spliced halfway through. So of course we're going to go to the joint properties for that bottom flight, and we're going to start manipulating the landings here. So again, top landing, we can turn on both sides this time. Better view. We don't want the cover. Let's get those beams the right length so we can make them 500. Offset the beams upwards, of course, like every other beam. And don't forget to create the last tread. But we can actually make the tread go all the way back, even though the landings are going to split in the middle. So take that out and tell it we want the dimensions of this tread to be quite a bit deeper. So the bracket, because we've got two split beams, we can only put the bracket on one of them, so I'm going to offset it a long way from the back of the tread and make sure we get the right distances between everything. Like so, so you can see now the angle bracket is just on that first beam, and we'll need different brackets for the back beam on the other flight. So that's the bottom flight done. The upper flight, we can edit that one. Straight to the landings, and we've got the bottom landings options, so we'll turn on both beams for the bottom landing. Make sure it's the right section. We don't need a cover. We're not going to do a bottom tread, we've already got the tread. Set the length appropriately for the beams. And the offset, of course. And as simple as that, we've got all the beams lining up nicely. So we're going to copy, have a look at the bracket underneath. So start off with a simple end plate splice between the two pieces of stringer. Standard joint, so there's no difficulty about that. Having placed one, we can copy that to the other side. elements, or advanced copy as it's known in other countries, to copy these two beams, the brackets. Don't forget to include the bolts and the welds, and we want to copy them from that position forwards to the end of the beam in that position. And we're only going in the next direction. We just had a little bit of an adjustment there to give it an offset, and it's in there. In fact, we can stretch those back and make room for another bolt, so let's add a bit more length to those. And we can edit the bolt patterns to make them 3 each, so that make sure the spacing is maintained. It's come up off center, we just need to move them a little bit, so we can move them up. And we're going to reference the beam, so it's going to go from the center of that bolt. We want it in the middle of the beam, so we go to the midpoint of that beam, and we're only going in the X direction, so we can untick the other two, like so. So that's got those bolts in the middle of that bracket. Check our assemblies. Yep, the bracket and the string are all part 1 assembly, and the same on this side, so that's good. Happy with that, clear marking. Right, just up to the top now. At the top landing, we've got a return to the right, where it's going to go to that doorway. So we're going to build this up out of various pieces. So of course we're going to start with the stair macro to get as much as we can. So into the landing options, we're going to have, let's do both beams. Depending on how you want to create it, there's various options. We'll set the length, we don't want to cover. Right lengths. Don't forget the offset everywhere, keep things consistent. Now turn on that last thread and to go and adjust the parameters of that thread. Turn off that back clip. Okay, so we've got a lot of the landing straight away free of charge. Adjust the angles underneath that thread, make it nice and long. Get the right number of bolts. We can only have 2 bolts again, but we can get the right spacing. We'll copy those as needed in a second. So copy that bolt and that bolt. And we're going to have another set this direction and another set this direction. So we've got plenty of bolts holding that plate down. Now with this beam here, you've got to go to the side, we can't have that trip hazard in there, so we can simply use a cut to remove the top of that beam. So we're going to go set our UCS in the right place, rotate it, then we're going to use a simple contour to cut the top off that beam as required, like so. So we've cut the slot to have the landing going to the side. Back to our coordinates and draw in our extra beams we need. So it's from A to B. And set that one. And then another one from right to left. And notice you can draw the toes the right way by drawing it from the right start and end in the right direction. And the settings are the same for that beam. So you've got the beams in there. Now to get the cover plate, I'm going to copy this plate from lower down. So just to help me see what I'm doing, I'll use wireframe. I'm going to use the advanced copy or transform elements, whichever you know it as. I'm going to select the plate. I'm going to take the brackets with me as well. And find the bits and pieces with it. And I'm going to copy that from this corner up to this corner. Get the right offsets in all directions. Just allow for the thickness of the plate there, the right amount. There you go. And you've got a plate in there. Now obviously that needs a bit of adjusting. So we can take off this fold, delete folded plate relation, delete some of these screws, we've got too many screws in there. Delete that back clip. And now we need to make things shorter, so we can use the AutoCAD, I'll set the UCS normal again, go to the top view, we can use the ordinary AutoCAD stretch command to get the side of the plate. Don't want to do that with that. And I want to move it to the right. I can use the point filters to make sure I only go in one direction. Move it to the right there. And then I want to stretch the top down. So another stretch. I want to go from the edge there and the Y direction to the edge there. And there you go, that's moved the plate, shrunk it and got it the right size. And there's our landing finished. So as you can see, you have some very powerful stairs. So let's review what we've just seen. Some key points to remember there. Top and bottom treads in each flight can be different to all the others. You have the group here for step top and step bottom. Once you remove the tick saying same as other steps, you can adjust the shape and size of that tread. And by doing that, it gives you a lot more options for landings or how you meet up with the floor at either side of the stair. Then you've got the landing cover, which can be used. It can be a grating, it can be a plate, or you can turn it off. And you can use that create last tread or create first tread options, again, so that you can use treads rather than landing covers, and that gives you a lot more flexibility with how you connect up to the landing or how you create the landing. And you can copy elements from within the macro to elsewhere, such as the support brackets for the landing. You can copy that around, you can extend it, you can manipulate it once it's copied. And that saves having to create all those objects from scratch. Saves a lot of time. And at no point did we delete any joint boxes. You can add features, you can copy parts, you can add welds, you can manipulate things outside the macro and add things to the macro, features to the macro objects without damaging the macro itself. So everything I've just shown you is using this standard built-in advanced steel stair macro and tools. They're very nice tools, but they can't do everything conceivable. Graitec produced a suite of extra tools for advanced steel known as the Power Pack or Power Pack Professional. And that gives you a range of macros and joints and connections and data and other tools on top of advanced steel, which are nice to have extra tools. Particularly relevant to this is we also have an enhanced level of the Power Pack, which includes special extra powerful stairs and railing tools. And these stairs and railing tools can do a lot more than the built-in tool. For example, they can do plate stringers, they can do the return landings all within the macro, and so on. And those enhanced stair and railing tools, they're known as Power Pack Premium. They used to be known as BIM Designers, now they're known as Power Pack Premium. And my colleague Rob Merriman has done another webinar doing a similar model to this one, where he does the whole thing using the Power Pack Premium stair tools, and he shows you how the landing can all be created within the tool. So basically you only have 2 macros to do the whole job, which is really powerful. If you'd like to see how he does that, then that was presented as part of the BIM Up conference. So log into the Graitec Advantage website, then look under videos, BIM Up 2020, and you'll find it listed as a secret to Power Pack Premium stairs. So have a look at that, really worth watching and comparing the tools. These enhanced Power Pack Premium tools are really powerful. Now, getting advanced steel is one thing, but to make it most efficient, there's a lot more than just installing the standard software. And we like to break this down into 5 steps. So the first step is to get some basic training. Please don't try and use advanced steel without any training. If you do, you might be able to fumble through and get some kind of model there, but there's a lot of subtleties and a lot of things you won't know unless somebody explains it and shows it all to you, especially when it comes to getting the right documentation out of the system. So don't fumble through without training. Get some training. You wouldn't buy a brand new piece of industrial machinery and try and fumble through guessing how to use it. You'd get trained on that, wouldn't you? This is a major tool for you. Get the right training. But even the training is just the first step on your journey to being efficient with advanced steel. You've got to implement advanced steel correctly. So that means installing it correctly, setting up the basic settings and options within advanced steel, creating the right borders and title blocks for your drawings and things like that. So that's an important task to do. Most customers can try and tackle that on their own, but we can do that for you so you can hit the ground running without having to get confused with these diversions. But beyond that, the drawings created by the system, inevitably the drawings created as a standard system are going to be a compromise because everybody does drawings differently. Whether we like it or not, that's the reality. So they're never going to please everyone with what's in the box, but we can tailor and configure those drawing rules to suit more closely how you like to do your drawings. And it's not unusual to be able to reduce the editing time by 30, 40% or even more, 50%. So greatly reduce your manual editing time on all the drawings. This is something I think every company would benefit from, having these drawing styles customized to suit their needs. We can also go beyond that with other areas of the databases. So we could create extra nuts and bolts, we can create extra beams, we can add custom connections, we can create standard parts. Many other areas of the database we can configure and set up for you to suit your company requirements. So you get maximum efficiency out of the products. Everything's just there waiting for you to use, optimized. And then all that customized data, there's a lot of customization going on now. If you have more than one user, you need to be able to manage that data correctly, make sure all the users are using the right data and the right configuration, and we can help you with that, create batch files or whatever might be beneficial there. So Graitec can help you with all these things. If you're trying to run solo without any help, you're not going to be getting anywhere near the maximum efficiency from your software. It's a good investment in your business, but to really make the best out of that investment, let Graitec help you. We're here to help. Consult Graitec. We can help you with these all 5 steps to really maximize your efficiency and the benefits advanced steel will give your business. Okay, so we've just got a few minutes left to talk about any questions anyone has. So if you've got any questions, there's a question and answer panel in the GoToWebinar interface. Please type your questions in there. I see one has been put in there. Sometimes I get different stair widths when I use joint copy to translate the stair. I usually edit anyway to get what I want, but is there anything I'm doing wrong? No, you're not doing anything wrong. We've noticed this ourselves when we do the training. If you use joint copy to copy a stair, although the width is filled in correctly, when you look at the properties inside the macro, it seems to ignore that width and actually just give you the standard 1000 wide stair. That's obviously a bug. It's been around for a couple of years now. What I find is I change the width value back to 1000, then type in the correct value again, and the stair width will change to the correct width. But though it changes the correct width, it's often offset one side or the other, the correct position at that point. So it does seem to lose the plot a bit with the stair width if it's not 1000. If it is offset one side, we showed in the video there, when we're doing the moving the stair around or copying the stair, use the transform elements and you can move the stair, set it to the move option. The object you want to move is just the joint box around the stair. Don't try and pick everything, just pick the joint box around the stair and then pick the right points to move it to the one side if you need to move it sideways. And you can untick the X, Y or Z boxes so it only moves in the direction you want to move in and doesn't go up or down depending on the reference points you chose. You don't want it to suddenly move up by 20 mil, so you can untick one of the boxes to say no, I only want it to go in this way, and you're able to get the stair back in the right position. Something we actually do in our architectural metalwork training day, which is the day we use it out of our standard course. There's 4-day standard training. The 5th day is architectural metalwork, where we go through creating straight stairs, spiral stairs and some railings and things, and it's something we do cover in that. So I would say it's a bug. You're not doing anything wrong. Unfortunately, at the moment, that's just the way it misbehaves slightly. When you do joint copy, it does do the stair width incorrectly. Change the value back to 1000, change it back to the right value again, and if necessary, move it sideways. So I hope that answers that question for you. Has anyone else got any other questions? Oh, I've missed half the lecture. Can I watch what's... Okay. Yeah, if you've missed anything, the whole presentation is recorded and it will be on the Advanced Steel portal. So download the handout from the panel on the right, the GoToWebinar interface. Download that handout now. It's got a link on the handout to the Advanced Steel Content Center, where we list all our previous webinars. There's over 50 there. This one will be added to the list within the next couple of days, and you can watch the whole thing as many times as you like. So I'll wait just a minute or two more, just in case anyone else wants typing in a question. You'd like some more information about the training, if you contact your local Graitec office, then we can certainly offer advanced steel training. If you're in the UK, or you contact Graitec UK, we offer standard advanced steel essentials course is 4 days. The first day covers modelling with all the standard tools. The second day is manually constructing things like plates and joints and welds and checking your model and everything else. So the first 2 days are modelling. Everything we consider essential to be able to model pretty much any building. So Advanced Steel Essentials is the name of that basic course. And then we have an optional 5th day. The next 2 days are documentation, where we talk about how to create the drawings, the efficient way to create the drawings based on the UK build. Lots of subtleties going on there, lots of information you won't get elsewhere. How to really get the most out of your drawings. Make sure you're getting the right drawings, the best you can get out of the system. No point in spending hours manually editing a drawing if you could have just changed 2 settings to get a better drawing in the first place. So how to get the best possible drawings out of the system, and then how to do the manual editing correctly so that it remembers that and stores that when it updates and doesn't lose it all. And also other types of document NC sharing with other systems, how to configure your system, how to create your title blocks and borders and bombs and so on. And then we have an optional 5th day of training, which is the architectural metalwork. And then the architectural metalwork day is just modelling. It's more of an intermediate level. So we kind of assume you're happy now with the first 4 days, and we just create straight stairs, spiral stair, railings going up the straight stair, railings going up the spiral stair, and we also use glass infill panels on the straight railings and show you the best way to do that, and freestanding glass on the platform, show you how to do those. So that's the architectural metal day, which is an optional extra. So that's what we offer in the UK. Other offices might offer something slightly different, but should be much the same, generally the same idea. So I hope that answers the training question. Another question, can you have any other type of tread cleat apart from rolled steel angle? Not at the moment. It is limited to angles. The PowerPack Premium Stair will let you have different configurations. You can put in plates there, but within the built-in standard tool, it's only locked onto angles at this time. Whether they'll ever change that, I don't know. Okay. So I don't think there's any more questions. Once again, Shanila, the name of the course you're looking for is Advanced Steel Essentials. So talk to Graitec UK or Graitec in your nearest office to ask for the Graitec Advanced Steel Essentials course, and possibly the Architectural Metalwork course as well. Okay, I think that's all the questions, so I'm going to shut down there. Thanks for attending. I hope you found that useful, and you can watch the recording again in a couple of days. Look out for it on the Advanced Steel Content portal. Thanks very much, everybody. Bye-bye.